Hi, hello, welcome back to my channel. Uh, Today our topic is EAMCET bits part 2. Let's go to the next problem. If two vertices of an equilateral triangle has integral coordinates, then the third vertex will have option 1 integral coordinates, option 2 coordinates which are rational, at least one coordinate irrational, coordinates which are irrational. Explanation. To solve the problem, we need to determine the nature of the coordinates of the third vertex of an equilateral triangle when the first two vertices have integral coordinates. First one, understanding the problem. We have two vertices of an equilateral triangle with integral coordinates, say a x1 y1, b x2 y2. First, we need to find the nature of the coordinates of the third vertex, c x3 comma y3. Next one, area of the triangle. The area A of triangle ABC can be calculated using the determinant formula. We know that the formula for area of triangle, it is A is equal to half mod x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This area must also equal the area calculated using the formula for an equilateral triangle, that is A is equal to root 3 by 4 into side whole square. Next, find the length of the side. The length of the side S can be calculated as the distance between points A and B. That is S is equal to root over the, we know that the distance formula is root over x2 minus x1 whole square plus y2 minus y1 whole square. For squaring on both sides, we need s square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. Next, area in terms of side length. Substituting s square into the area formula for the equilateral triangle gives A is equal to 3 by 4 into x2 minus x1 whole square plus y2 minus y1 whole square. Fifth, nature of the area. Since x2 minus x1 whole square plus y2 minus y1 whole square is rational, since as it is the sum of squares of integrals, the area A becomes A is equal to root 3 by 4. That is rational. Since root 3 is irrational, A itself is irrational. Conclusion about the third vertex. For the area calculated using the determinant to be equal to the area calculated using the side length, the coordinates of the third vertex C x3, y3 must be such that the overall area remains irrational. This means that at least one of the coordinates x3 or y3 must be irrational. Final answer is thus, if two vertices of an equilateral triangle have integral coordinates, the third vertex will have coordinates that are not both rational, implying that at least one of them is irrational. The right option is at least one coordinate is irrational. Next sum. If x1, y1, x2, y2, x3, y3 be the coordinates of the vertices of a triangle such that xi and yi for all I is equal to 1, 2, 3 are rational numbers, then which of the following has not necessarily rational coordinates? Option 1 incenter, option 2 centroid, option 3 circumcenter, option 4 orthocenter. Explanation for incenter. Let vertices of triangle ABC are A is equal to x1, y1, B x2, y2, C x3, y3, where x1, y1, x1, x2, x3, y1, y2, y3 belongs to rational numbers, that is Q. Next, we calculate the distance from A is equal to BC. We know that the formula for distance formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. It is equal to rational, or it may be rational or irrational. Similarly, B is equal to C, C is equal to AB. Then in center, we know the formula for in center, that is ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. Therefore, in center has rational or irrational coordinates. Next one, centroid. To compute the mean of x and y coordinates of the vertices respectively, which are obviously rational. Next, circumcenter. The middle points of each sides are rational and the sides lies on the lines through two rational points, so they are rational. Orthocenter. The solution of equation of lines of altitudes orthocenter would be a rational point. Therefore, the right option is in center. Next sum. The center of the circle which pass through the vertices of a rectangle is first option, midpoint of the diagonal. Option 2, one vertex. Option 3 divides one diagonal in the ratio 1:2. Option 4 divides one diagonal in the ratio 2:1. Explanation. If we can draw a rectangle with for four sides A, B, C, D with the center O. Consider ABCD as a rectangle. We know that O is the point of intersection of diagonals AC